Welcome back to the Table Talk series, where we go over the Test and Inspect table of Chapter 14 of the NFPA 72 2025. Today we're going to cover component number 5 of the series. Stay tuned to the end, so we will have some questions which you can answer, test your knowledge to see what you've learned. We go over hopefully all 30 components of the Test and Inspect chapters, one video at a time. So we're on video number 5, which is component 5. So let's begin. So we are covering the NFPA 72 2025 National Fire Alarm and Signaling Code. Chapter 14, which is the Inspection, Testing, and Maintenance Tables. This is your educational field guide, again for component number 5. And component number 5 is going to cover the table 14.3.1, which is the inspection table, and 14.4.3.2, which is the testing table. And this is going to be the emergency communications equipment. So, in building fire emergency voice/alarm communications equipment, ECS, provides the ability to transmit voice instructions and alarm signals throughout a building during a fire or emergency event. This includes the amplifiers, tone generators, phone jacks, handsets, and associated control equipment that make up the voice, evacuation, and firefighter communication system. These systems are critical for life safety. They allow fire department personnel and building staff to communicate with occupants throughout the building and coordinate evacuation. Unlike other alarm components, these require periodic verification of voice quality and clarity, in addition to functional operation. Table 14.3.1 requires a semi-annual visual inspection to verify location and condition. Table 14.4.3.2 requires the annual function testing of 6 subcomponents covering all major system elements from amplifiers to full system performance. So here we have a little kind of diagram, kind of summarize the whole slide deck, but this is component number 5, ECS system overview. We have our main ECS control, the FACU voice panel backup power switching. We have the different subcomponents. We have number 1, amplifiers and tone generators, backup switching, tested annually. Number 2, call-in signal silence, visual plus audible, tested annually. Number 3, off-hook indicator, ring down, tested annually. Number 4, phone jacks, inspect plus path test, test annually. Number 5, phone set, actuate each handset, test annually. And number 6, system performance, 5+ handsets simultaneous, test annually. Table 14.3.1, visual inspections done semi-annual. In building fire emergency voice/alarm communications equipment, verify location, verify condition. All right, so just kind of a quick overview of everything we're going to go over today. So let's break it down now. So going to go first, the NFPA 72, table 14.3.1, which is our visual inspection for in-building fire emergency voice alarm communications equipment. It's a mouthful. All right, so it's inspection only. Table 14.3.1, component number 5, requires a semi-annual visual inspection. This is a visual check only. No signals are transmitted and no equipment is operated during inspection. Per Code 14.1.6, 2025 edition, inspectors are not required to reevaluate the design adequacy of a previously approved system. Basically, you test and inspect the system as designed. So, in building fire emergency voice alarm communications equipment, again, in test or inspect table 14.3.1, and it's done semi-annually. So, visually inspect all in-building fire emergency voice/alarm communications equipment at the protected premises. 2 checks are required. First, verify location. Confirm all ECS equipment, control panels, amplifier racks, remote phone cabinets, and jack locations is installed in the correct designated location for the record of completion. Equipment has not been moved, relocated, or had its access obstructed. Second, verify condition. Inspect all ECS equipment for physical damage, missing covers or enclosures, loose wiring connections, corrosion, water intrusion, or signs of tampering. phone handsets are present and properly stored at each phone jack or each jack location. Again, testing or inspection basis, semi-annual frequency, twice per year. Unlike most other inspection items that are annual, ECS equipment requires inspection every 6 months. Schedule inspections to keep them within the 6-month window. Any deficiency found, damaged equipment, missing handsets, or obstructed access must be documented and reported to the qualified service technician. All right, so that covers our visual inspection table. Now we're going to get to a testing table. So this is NFPA 72 again, table 14.4.3.2, which is the testing table for the emergency communications equipment. And this is done by your qualified personnel on an annual basis, so your technician. So all 6 sub-items are tested annually. Testing shall be performed by qualified personnel. Notify all affected parties, occupants, supervising station, and building owner per code 14.2.4.1 before testing. Restore all systems to full normal operation at the conclusion of all tests. Per 14.1.6, 2025, testing personnel are not required to evaluate design adequacy of a previously approved system. Right, same thing. So number 1, amplifier tone generators. For 14.4.3.2, the testing table. This is done annually, right? So verify correct switching and operation of backup equipment. Emergency communication systems require backup amplifiers and or tone generators to maintain system operation in the event of a primary amplifier failure. This test confirms the backup switching functions correctly. So step 1, verify the primary amplifier and tone generator are operating normally at the start of the test. Next, simulate a primary amplifier failure or manually switch to backup. Verify the system correctly switches to the backup amplifier and or tone generator without interruption of system operation. Next, confirm the backup equipment produces the correct output levels and signal quality. Next, verify a trouble signal or fault indicator is generated at the control unit when the primary unit fails. And finally, restore the primary equipment and verify the system returns to normal operating condition. Bonus note, right? Why backup switching matters. In a fire event, the ECS must remain operational even if a primary amplifier fails. Backup switching ensures continuous voice communication capability throughout the emergency. A failed backup switchover could leave entire building zones without voice evacuation instructions, right? So if the primary goes down, then you're not going to be able to function the device, right? If you don't have the backup power, right? So you always have to have power, whether it's primary power, backup power for your system. So that's what you're testing for. You're just making sure it switches and you're making sure the backup power is working. So number 2, call in signal silence. For test table 14.4.3.2, this is tested annually. Okay? Operate/function the call-in signal silence feature and verify receipt of the correct visual and audible signals at the control unit. The call-in signal is used by building occupants or fire department personnel to request communication via a phone jack. The silence feature allows the fire command station operator to acknowledge and manage incoming calls. So if someone calls in and the operator at the panel hits silence, right? So first, initiate a call-in signal from a remote phone jack location by going off hook on a phone connected to a jack. Verify the control unit produces the correct audible call-in signal tone or ring indicating an incoming call from a remote location. Verify the control unit produces the correct visual signal, LED or indicator, identifying the call location. Operate the call-in signal silence function at the control unit. Verify the audible call-in tone silences correctly. Verify the visual indicator remains active after silencing, identifying the call-in location until the call is answered or cleared. So you call in on your phone, the operator at the main panel acknowledges the call, and then they silence it, right? right? Making sure you can silence that call. So pass criteria. The call-in signal produces both a correct audible and a correct visual indication at the control unit. The silence function stops the audible tone. The visual indicator correctly identifies the calling location and remains visible after silencing. All right. Next, number 3, off-hook indicator, or parentheses ring down. Test table 14.4.3.2, tested annually. All right. Install a phone set or remove a phone from the hook and verify receipt of the signal at the control unit. The off-hook indicator, also called the ring down feature, notifies the fire command station when any phone jack on the system goes off hook, allowing operator to know when someone in the building is attempting to communicate. So if you have a phone that's on the hook, it's usually pushing down on a little lever, which means it's not active, and then you pick it up, the lever raises and now it becomes active, and then a signal gets sent to the panel, letting the person at the panel know that someone's trying to call in. Okay, so install a phone set at a phone jack or remove an existing handset from the hook, take off hook. Verify the control unit receives and correctly displays the off hook signal, indicating which jack or zone the signal originated from. Confirm the indication is correct and unambiguous. The operator can identify the originating location without confusion. Replace the handset on the hook, and verify the off-hook indication clears at the control unit. Repeat this test at a representative sample of jack locations throughout the system. Okay. So here's a little bonus. Ring down explained. Ring down, in parentheses, refers to the automatic connection that occurs when a handset is lifted. Unlike a normal telephone that dials a number, an ECS phone jack instantly connects, right? Instantly connects to the fire command station when taken off hook. This is the primary communication method for firefighters operating in a building during an incident. That's kind of a lie. Modern firefighters just use radios, but I mean, they have these in the building for a reason, where if the firefighters didn't charge their radios, forgot their radios, lost their radios, they're broken, whatever, there's still means for communication, right? But yeah, so the phone is on the hook in its normal state, doing absolutely nothing. Nothing's happening. When you go to take the phone off the hook to use it, it instantly calls into the panel, right? That's how it works. Number 4, phone jacks. Table 14.4.3.2, tested annually. Visually inspect each phone jack and initiate a communications path through the jack. This test combines a physical inspection of each jack with a functional verification that the communications path is operational through that jack. Visually inspect each phone jack enclosure. Verify the cabinet is undamaged, properly secured, and accessible. Verify the jack connector is clean, free of corrosion or physical damage, and properly installed. Plug a phone handset into the jack and initiate a communications path. Verify two-way voice communication is established to the jack to the fire command station. Verify the jack identification label is present, legible, and correctly identifies the jack location for the system documentation. Remove the handset and verify the jack returns to normal standby condition. So these are, I have a video on this one, actually. There's like the phone test sets where it's a regular phone in your hand and it has a cord coming off with a little phone jack. And you plug the phone jack into the wall outlet. And as soon as you plug it in, it calls to the fire panel, right? And when you unplug it, it hangs up, right? So you're testing that function. So test every jack. Each individual phone jack must be visually inspected and functionally tested, not just a representative sample. A single non-functional jack in a stairwell or elevator lobby could leave a firefighter without communication in a critical location. Document each jack tested and the result in the test record. Again, modern firefighters use radios, right? But these systems are still in these buildings. They were put in years and decades ago, so we still test them, right? Just in case. You might have a firefighter, like I said, who forgot his radio, didn't charge it, broken, whatever, and they need a way to communicate. So we have these systems there in place. Number 5, phone set. For again, test table 14.4.3.2, tested annually, right? Actuate each phone set and verify correct operation. Excuse me. Where dedicated phone sets, in parentheses handsets, are permanently stored or deployed at phone jack locations, each unit must be individually activated and verified functional. Remove each phone set from its storage position and actuate, in parentheses, take off hook or press the talk button as applicable for the handset type. So you do have push button handsets, and then where you push to talk, or you lift up the phone to talk. So that was the first one. I should have highlighted that. Next, verify. The phone set establishes communication to the fire command station correctly. Verify the transmit and receive audio are both functional. The operator at the control unit can hear the remote handset, and the remote user can hear the operator. Check the physical condition of each phone set. Verify the cord, connector, and handset are undamaged and properly functional. Return each phone set to its storage position and verify it is correctly stowed. So with all these, you're checking your phone set, you're checking your jacks, you're checking your wiring, you're checking the outside, how it looks, you're checking two-way communication, right? You're going through the same check process for all these. Bonus note, two-way audio verification. This is important. Simply establishing a connection is not sufficient. Both the transmit path, remote to command, aka from the phone you're calling from to the fire panel, and receive path, command to remote, aka from the panel to wherever the phone jack is being tested, must be verified. A phone set with a failed speaker will not allow a firefighter to hear evacuation instructions, even if the microphone is working. Verify both directions of audio for each set. So I've had this personally too, where I'll test a phone set and I call to the panel and they could hear me, but they're talking to me through the panel phone to where the jack I'm testing, and I can't hear them, and vice versa, or they can't hear me, I can't hear them. Something's wrong, right? So it's two-way communication. You can't just be listening or just talking. You need to be able to talk and listen. Number 6, system performance for test table 14.4.3.2, tested annually. Operate the system with a minimum of any 5 handsets simultaneously and verify voice quality and clarity. This is the full system load test. It verifies the ECS amplifiers, wiring, and distribution equipment can maintain acceptable voice quality when multiple users are active at the same time, as would occur during an actual fire emergency. Simultaneously connect and activate a minimum of 5 handsets at different jack locations throughout the system. With all 5 or more handsets active simultaneously, verify that voice communication is intelligible and clear at each handset location. Verify voice quality and clarity from the fire command station. Speech transmitted to the building must be clearly understandable at remote locations under simultaneous load. Verify voice quality and clarity from remote locations back to the fire command station. Multiple simultaneous call-ins must be distinguishable and clear. No significant audio degradation, distortion, crosstalk, or signal dropout should occur under the simultaneous 5 handset load. I will say I've never done this with 5 because I've never been dispatched to a job site where there's 5 technicians there testing a system. So I don't know. I don't want to speak to the practicality of this, but it doesn't happen. At least not for me. It's never happened. I've never had anyone have 5 people on site to test 5 different phone jacks simultaneously. At best, usually it's like 2 people, maybe 3. But minimum 5 handsets simultaneously. The standard specifies a minimum of 5 handsets active at the same time. This is not 5 sequential individual tests. All 5 must be connected and communicating simultaneously to test the system under realistic emergency load conditions. More than 5 may be used in the system design support if the system design supports it. Voice quality that is acceptable with 1 handset may degrade significantly under simultaneous load. Again, that's very, very rare. Having 5 people on a site at one time just for this test, I've never seen it, right? So good luck with that one. Anyway, knowledge check. Let's see what you've all learned. Have you learned anything today? Did you learn anything watching this video? Has it benefited you? Let's find out. There are 3 questions. Let me know your answers in the comment, right? So on the knowledge check, component number 5, emergency communications equipment. It's for the NFPA 72 2025 edition. This is for the inspect table 14.3.1 and test table 14.4.3.2. Select the best answer for each question. All right. Question 1 of 3. How does the visual inspection frequency for in-building fire emergency voice alarm communications equipment under table 14.3.1 differ from most other components in chapter 14? And what 2 things must be verified during each inspection? Is it A, it is the same as most other components, annual, and requires verifying location, condition, and system normal condition, 3 checks? Is it B, it is monthly, more frequent than most components, and requires verifying voice quality and the presence of all handsets? Is it C, it is quarterly, the most frequent of any component in Chapter 14, and requires verifying location, condition, and functional operation of all handsets? Or is it D, it is semi-annual, more frequent than the annual inspection required for most other components, and requires verifying 1, location, and 2, condition of all ECS equipment? Which do you think it is? Tell me in the comments what's your answer. All right. Question 2. During the phone jack test under subcomponent 5, number 4, subcomponent 4, a technician visually inspects each jack and tests communication through it. What is the scope of jacks that must be tested, and what specific aspect of the test verifies the communications path is functional? Is it A, a representative sample of jacks, at least 1 per floor, and the test is passed by confirming the jack connector is free of corrosion? Is it B, every individual phone jack must be tested, and plugging a handset into each jack and verifying 2-way voice communication is established through that jack to the fire command station is what confirms the communications path is functional? Is it C, only jacks in stairwells and elevator lobbies? These are the life safety critical locations, and the test is passed by confirming the jack enclosure is undamaged? Is it D, every jack, but the communications path test only requires verifying the jack produces an off-hook indication at the control unit? 2-way audio is not required at this test level. Which do you think it is? What's your answer? Let me know in the comments. All right, and finally, question number 3. During the system performance test under subcomponent 5, subcomponent 6, what is the minimum number of handsets that must be active simultaneously, and what specifically must be verified while they are all connected? Pardon me. Is it A, a minimum of 5 handsets simultaneously, all active at the same time, not sequentially, and voice quality and clarity must be verified with all 5 connected to confirm the system maintains acceptable performance under simultaneous load? Is it B, a minimum of 2 handsets, 1 at the fire command station and 1 at a remote location, and the test verifies that the amplifier switches to backup correctly under load? Is it C, a minimum of 3 handsets on separate floors simultaneously, verifying that the system can page all zones at the same time without signal dropout? Is it D, all installed handsets must be active simultaneously, and the test verifies no off-hook indicators are missed at the control unit? What do you think? What is your answer? Let me know in the comments. All right, and that's the end of component number 5. So as I said, this is covering the test and inspect tables, right? 14.3.1 is your visual inspection table. 14.4.3.2 is your testing table covered under chapter 14. Right? Component number 5 is what we went over today. So this is our 5th video. So go ahead and try to answer these questions. Let me know your answers in the comments and I'll review them for you. And we will continue on to the next component. This says next component number 7. That should be 6. That's my mistake. Anyway, thank you all for watching, and I will see you in the next video.